Hey, so we're back again. This is part B to part 5 of grade 6 of Show Your Work. Okay, I'm just going to continue on with this. I originally skipped this one on the other one because a lot of students get this problem wrong. Turns out, interestingly, there's many ways to solve this. So let's look at the illustration for starters. Let me see if my tablet's going there. So we have the length at the top is 14. Okay, the length of the bottom is also 14. So because this 5 plus 3 here, if we say that's 8, it's probably a valid assumption that if I was to do this, that this is probably 8 as well. Okay, we don't know yet. We have to read the words. It does not tell us in the illustration. In other words, it doesn't say this is a 90-degree angle and that's a 90-degree angle. However we do this, we notice there's a shape here. I'm going to call it A. There's a shape here. I'm going to call it B. And there's a shape here. Once I drew that blue line, there's a shape C here. There's also the outer shape, which if it's a rectangle, we can call that shape R for rectangle, all right? It turns out that shape A and B are trapezoids. This is a trapezoid here. It's upside down, if you will. And this is also a trapezoid here. A regular trapezoid looks like this. I'm drawing it the best I can. Okay, but we can take a side and just chop it off like that and be left with a shape like this in here. That's supposed to meet there. All right, so that's what A and B are. Those are the shapes. They're both trapezoids. They're irregular trapezoids. C is clearly a triangle. Okay, without having read the words yet, it may be that I want to eventually cut into here and create two rectangles. This rectangle right here, if indeed they're rectangles. All right, let me try that again. It's not following me. I may have to reboot after this. And this rectangle down here, okay? So with all that said, I'm going to erase all the scribblings I just did here because I don't know what else to do with the illustration. I don't know what they want us to do with it. Most likely, they're going to ask us for the area of something. That's normally what happens in cases like this. Okay, so let's clean this up. Enough you probably want me to erase this completely and leave it erased, but otherwise we wouldn't be doing the problem there. All right, is that everything? Yeah, I think all the dirt's gone. Nope, there's maybe a little right here still. Okay. Yeah, let's get rid of that just so for cleanliness purposes. So David made a class banner. Okay, so this is a banner, right? If we have, a flaggy thing. So we have a banner out of a large rectangular piece of paper. So originally it was a rectangle and he cut this part out. Okay. In fact, it says that. He cut out the triangle piece on the one side as pictured below. So it originally was a rectangle here. So we can go and do that assumption. This was a right angle, and this was a right angle. Okay, as pictured below. What is the area in square inches of the banner? Okay, so we have a whole bunch of what's called composite shapes. I've talked about this in multiple videos. Maybe part 4 to all this, I mentioned it. I also mentioned it in the grade 5 videos. I think it also was covered in the multiple choice ones. Again, if you go to the GregsTutoringNYC at gmail.com/hardest-math, you'll be able to see that there. Okay, and again, investigate those other videos. This is a good point to say, please subscribe to my channel. Please like and subscribe to the video. This is a lot of work. I hope you guys get something out of it. Please welcome yourself to me, and you can email me any questions you guys have. All right, so what is the area of the banner? Okay, so there's a couple ways to do this. Let me bring this as high up as possible so that I have enough space to work with. So let's work with the most top level one. In fact, let me start from over here and we'll work our way down. The area of the rectangle, okay, that's equal to 14. So it's the length times the width. So that's equal to 14 times 5 plus 3. Okay, so it's equal to 14 times 8. Okay, and that's equal to 80 plus 32. Is that 112? Let me go over here and just make sure. 14 times 8. 8 times 4 is... Yep. Again, you guys should know this. So what we have is the super thing. And what I want to do is pull out of that this triangle. Okay. So we need to figure out the area of that triangle is equal to 1/2 BH. Now, some of you might think, well, if we split the triangle up into 2 right triangles, we can figure out each. But that's a triangle on its side, if you will, as well. Right? Another way to look at this triangle is, if this is the base over here, the base of the triangle, okay, we have stuff like this. So its base is the 5 plus 3. So that's 8. Its base is 8. Okay. Its height, can we figure out its height? Its height is from here to here. Well, if we know this is 11, the height must be 3, right? So we can get is equal to 1/2 of the 5 plus 3 times the height, which is the 14 minus the 11. Okay, so that's equal to 1/2. 8 times 3, I believe, right? Did I do that right? So I get 4 times 3, and I get 12. So what I need to do now is remove the triangle out of that. So the area of the banner is equal to the area of the triangle, the area of the rectangle, minus the area of the triangle, right? So that's going to be equal to the 112 minus the 12. And that's going to give us 100. Okay? And by the way, this was in inches, that's in inches, that's in inches, that's in inches, that's in inches. Okay, so there's no unit conversion. And then we're going to get square feet. Sorry, square inches. Okay, so that was one way to solve this. All right. Another way to solve this is to use the area of the trapezoids. So we have T1 and T2. Okay, so the area of a trapezoid, in this case T1, is equal to the sum of its bases, B1 plus B2, the average of that, so that's divided by 2, right, times its height. Okay, so in the case of T1, this 14 and this 11 are the bases. So we have 11 plus 14 over 2 times the height. In this case of T1, the height is 5. Okay, so we get, what do we get? 25 over 2 times 5. And that's 125 over 2. And if we divide that, we get what? 62.5. Did I do that right? Give me a second. Let me just double check that. We have B1 plus B2, 14, 25 over 2 times 5, 125 over 2, 62, 124, 100. Yep, we did that right. And then the area of T2 is going to follow the same thing. Base 1 plus base 2 for that is going to be, it also has a 14 and an 11. right? So we're going to get 11 plus 14 over 2. Instead of times 5, it's going to be this times 3 right here. Okay? So times 3. So we're going to get 25 over 2 times 3. That's equal to 75 over 2. And that is equal to 37.5. Okay? Now that we have the area of both trapezoids, which will be the whole area, that's the whole area we're looking for, all we need to do is add them up. So 5 plus 5 is 0. Carry my 1. 7, 8, 9 plus the 1 is 10, 0, 1, 6. I don't know why this tab is not writing. 6, 7, 8, 9, 10. 10. Put my decimal point in there. We get the same thing back here. Okay, so I'm going to change the color of the pen at this point, because at this point there's a multitude of other different ways to have solved this as well. With the purple, I'm going to come back and say we could have gotten this here, right? And we could have gotten the area of this rectangle here and subtracted out the area of this triangle. And then taken the area of the bottom one. Let me change the color again. And taken out this area. Okay? We could have also used these two areas as explained before. When doing the area of the triangle, we could still split them up that way. We could have also, let me change the color one more time. Let's make it brown. We could have dropped the line here across this completely. Gotten the area of this whole thing right here, okay, and then added this triangle and this triangle. All right, so that would have been another way to do it as well. And by the way, there's another way, because this is so, I'm going to erase this all and show you kind of an optimized way to do a lot of it as well. If we drop the line here, okay, this means inside here, we have a 14 by 8. Okay, we already said that that was 112. Wait, sorry, we have an 11 by 8. So this is 88. Okay, if we now, I'm going to change the color. Take the area of this whole thing right here. Yikes. Wait, give me 1 second. Let me erase that. If we now take the area of this, that rectangle right there, well, that's a 3 by 8. Okay, so the area in here is 3 times 8. Okay, that's equal to 24. So there's an interesting thing that happens here. If I drew this line straight into here, it turns out that this triangle here, I'm going to call it A, and this triangle here B, they're exactly equal. And this triangle here C, and this triangle here D, they're exactly equal. So if it was 3 times 8 is 24, it means the area of the red rectangle has to be divided by 2, because we're not including this, half of it, and we're not including D, half of it. So we're going to get 12. Okay, so now we have 88 plus 12. Okay, we get back to our 100. Okay, so there's a lot of strategies here. Some are more tedious than others. I would definitely go with the blue ones and this red way I did it. The red way in some ways is actually the fastest, but sometimes it's the hardest to see. All right, and there's other scenarios here. There's, again, a whole bunch of different other scenarios in here. Okay, so that is how to solve 39. I'm going to leave this as it is because I want to use this videos probably as an exemplar. Please like, please subscribe, please join the channel. There's tons more of this coming. Even when I finish all these show you work versions for grade 7 and grade 8, I don't stop. I'm always doing videos and other things as well. Peace, and I'll do that last question.